In this lesson, we're still looking at the same essential question: how can I apply the golden rule of algebra to solving equations? This time, our equations have a variable on both sides of the equal sign, so we need to first get our variables together before we try and get our variable alone. So what I like to do is look at my coefficients. Remember, a coefficient is a number that is being multiplied by a variable. Move the term with the smaller coefficient. -2 is smaller than 3, so I'm going to add 2n to both sides. Combining my like terms, 3n plus 2n gives me a total of 5n, bringing down my plus 2. On the right-hand side, my n's cancel, leaving me with a -8. Again, can't stress enough, be very careful not to lose those negative signs. Now we have a solve by undoing, so we're going to subtract 2 from both sides, because that adding 2 comes last in order of operations. On the left-hand side, we're left with 5n. On the right-hand side, if we spend $8 and we spend 2 more, we have spent a total of $10. So -8 minus 2 is -10. Canceling that multiplication of 5 by dividing both sides by 5, we're left with n equals -2. Second example, very similar to the first one. Looking at the coefficients of 8 and 7. 7 is smaller, so I'm going to subtract the 7y from both sides. 8y minus 7y leaves me with 1y, or just y, bringing down my -7. My 7y's cancel, and again I'm left with a -2, being very careful to keep track of our negative signs. Now we simply need to add 7 to both sides because it's the only thing with our y that we need to cancel. So we've got y equals 5. Now we're going to take a look at some variables on both sides that are a bit more complicated. So our first one involves some distributive property. The first thing that we'll need to do is simplify both sides of the equal sign if necessary. Looking at the left-hand side of my equal sign, 14 plus 3x, there are no like terms and there's nothing to simplify. So jumping over to the right-hand side, I'm going to distribute my -3 to both pieces inside the parentheses. Make sure you keep track of that negative sign and work down the page. Don't lose track of anything else in the equation either. So everything that I haven't identified as needing to be simplified, I'm going to write that down. The -3 times x is -3x, and the -3 times -4 is a positive 12. Next, I'm going to look for like terms on either side of the equal sign. On the right-hand side of my equal sign, I have 8x minus 3x. So again, keeping that left-hand side the same because there's nothing to simplify and I'm not canceling yet. And the right-hand side, 8x minus 3x is 5x, and I'm going to bring down my plus 12. Now that both sides are as simplified as possible, I'm going to get my variables together. So when I do that, I look for the term with the smaller coefficient. Between 3 and 5, 3 is smaller, so I'm going to subtract 3x from both sides. On the left-hand side, my 3x's cancel, leaving me with the 14. 5x minus 3x is 2x, and bringing down my plus 12. Now to get my variable alone, I'm going to cancel the plus 12 because adding comes after multiplying in order of operations. My 12's cancel on the right-hand side. 14 minus 12 is 2, equals 2x. And dividing by 2 to cancel my multiplication, I get 1 equals x. My next example, I have distributive property on both sides. On the left side, I'm going to distribute my negative sign, and on the right side, I'm going to distribute my 2. So the left side becomes -5a minus 6, and the right side becomes 6a plus 16. Getting my variables together by looking for the term with the smaller coefficient, I'm going to add 5a to both sides. So on the left-hand side it cancels, leaving me with a negative 6 because I'm not going to lose my negative sign. 6a plus 5a is 11a, bringing down my plus 16. Canceling my addition before I cancel the multiplication, I'm going to subtract 16 from both sides. Negative 6 minus 16, they have the same sign, so I'm going to add them and get a total of negative 22, bringing down my 11a and my 16's canceled. Finally dividing to cancel that multiplication, I get negative 2 equals a. And finally, we're going to revisit squares because we need as much practice as we can get on all of these different ways to solve an equation. Because subtracting comes after squaring in order of operations, I'm going to cancel my subtracting first by adding 12 to both sides. On the left-hand side, I'm left with k squared. The right-hand side gives me a total of 18. Because squaring and square rooting undo each other, just like adding and subtracting undo each other, I'm going to take the square root of both sides. So that gives me k equals the square root of 9 times 2. Remember, when we've got a radical, we always want to look for those perfect square factors so we can get our answer in simplest radical form. The square root of 9 is 3. 2 is not a perfect square, so it stays under the radical. And our last example, this time everything is in grouping symbols, so the square comes after grouping in order of operations. So I'm going to cancel the square first this time, leaving me with c plus 7 on the left-hand side. And the square root of 100 is 10, subtracting 7 from both sides to get my c alone. On the left-hand side, the 7's cancel, leaving me with c. 10 minus 7 is 3. Here are 3 U-Try problems for you. We'll start off class with these as warm-ups.